Hello, today we will discuss about how high pass RC circuit is acting as a differentiator. So this is a different high pass RC circuit. High pass RC circuit is a simple RC circuit where the output is taken across R. And remember that when R and C elements are in series, when an input voltage is applied, at that time a current flows into R as well as C. That means same current flows into C as well as R elements. Okay. Now V0 of T output response, that is response of high pass RC circuit, which is nothing but voltage across resistor itself, that can be written as voltage drop across that resistor I of T multiplied by R, where I of T can be written as, where I of T is the current flowing through the resistor. The same current is also flowing through capacitor. We can write in terms of capacitors like this: C into dVc of T divided by dt, where Vc of T means voltage across capacitor. Vc of T means voltage across capacitor. If RC is very small compared to the time applied for the input signal, capital T is the time duration over which input is present, where RC is the time constant of the circuit. If RC is very small compared to T, that means capacitor charges rapidly and the input voltage is applied for a sufficient amount of time so that capacitor can reach the input. If capacitor reaches the input voltage, then voltage across resistor is 0, because if you are applying 10 volts as input, if capacitor takes the 10 volts, then there will be no voltage remains across resistor. So if RC is very small compared to T, then voltage across capacitor can be approximately equal to V input of T. So substitute this value for this condition in the above current equation. So V0 of T, current equation is C into dVc of T divided by dt. Vc of T can be written as Vin of T divided by dt into R. So this can be written as RC times of D in V input of T divided by dt. That means V0 of T is proportional to dVin of T divided by dt. Output is proportional to differentiation of input. From this one we can say high pass RC circuit is acting as a differentiator, but the thing is it is only valid for this condition. If RC is very small compared to T, then V0 of T is proportional to dVin of T by dt. Okay. So when high pass RC circuit is acting as differentiator, what happens when different types of signals are applied? That we will see now. Assume that one high pass RC circuit acts as differentiator. So first input is, we will apply it as a step input is applied. If input is applied as a step, input is applied as a step signal of V volts magnitude. If it is input, what will be the output of this circuit? Output. So here you will get a impulse signal. Ideally what you are going to get is, it is 0, and after this one also output is 0, where you are going to get impulse. So for a step signal, if you are applying step input, then the output is impulse output. Impulse output. If you apply a pulse, if you apply pulse signal like this, input, pulse input, then the output is an impulse, a positive going impulse followed by negative going impulse, and again the input is 0. So this is the output waveform. Why you are going to get impulses at this one? Whenever a circuit is acting as differentiator, if you apply a step input means you are applying constant voltage from 0 to infinity, that is V volts. Constant differentiation is 0, so you will get 0. But what about the differentiation of sudden change 0 to V volts? That will be treated as impulse. When a voltage is changes suddenly from 0 to V volts like this, positive change, that will be giving a positive impulse. And for a pulse you will get two sudden changes at t is equal to 0 and at t is equal to Tp. At t is equal to 0, input voltage is increasing positively, whereas at t is equal to Tp, input voltage is decreasing negatively. So there is a positive impulse occurs at t is equal to 0, and later the voltage is constant, so output is 0, and at t is equal to Tp, again the input voltage is decreasing, that means a negative impulse appears. So if you apply pulse input, then the response of high pass RC circuit when acting as differentiator is two impulses in sequence depending on the pulse applied. For this, at t is equal to 0, a positive impulse, and at the end of that means at the start of pulse there will be an impulse, and at the end of pulse there will be one more impulse. Whether it is positive impulse or negative impulse, that depending on the direction of input. If the input is increasing, it gives positive impulse. If the input is decreasing, it gives negative impulse. So two impulses for a pulse input. Similarly, if you apply a square wave input, if you apply square wave input, square wave is nothing but series of pulses, it looks like. So you are going to get a positive impulse when the input is changes positively, and negative impulse when the input is changing negatively, when the input is decreasing, and when the input is increasing it is positive impulse, when the input is decreasing it is negative impulse. Like this you will get the outputs. So square wave input, for square wave input, series of positive and negative, impulses. And if you apply ramp input, ramp input is this one. So where assume that one slope of the signal is alpha. If you apply ramp input, then the output is looks like this. Then the output is a step signal. So that step is having a magnitude of alpha. That is, slope of the ramp signal will become step magnitude. Magnitude of step signal outputs. So you will get here it as square wave step outputs. Next, if you apply parabolic, similarly parabolic input, then the output is ramp outputs. So what happens when a sinusoidal input is applied for a high pass RC circuit which is acting as differentiator? So if you apply a sinusoidal input, what will be the output? Output is also of sinusoidal in nature, because already I have studied for a linear circuit, that is RC circuit. For a linear circuit, if you apply sinusoidal input, you will get the output also sinusoidal. So in general what we know is, if you apply a sine signal, you will get the cos signal as output for differentiator. Now we are going to say what will be the condition for perfect differentiation. or perfect differentiator. What is the condition for perfect differentiator? That we are going to discuss now. Okay. So this is we can get when we apply a sinusoidal input. When you apply a sinusoidal input, output is also sinusoidal, but there may be a change in the magnitude as well as phase. For example, you apply a sine pi as a signal. When you apply sine pi, the output is cos pi. Cos pi can be written as sine pi plus 90 degrees. That means if a sinusoidal input is applied, you are going to get sine signal. You are going to get, for a perfect differentiator, the magnitude is remains same, 1 into sine theta, 1 into sine pi. So magnitude remains same, only the phase angle gets differed. Okay, so magnitude is 1 and phase angle of output response is 90 degrees. Okay, now we are going to get a condition for a perfect differentiator by making use of this phase criteria. Already we have defined magnitude and phase equations. Phase equations for a response of high pass RC circuit when sinusoidal input is applied is tan inverse FL by F, or it is also written as tan inverse 1 by omega RC. Okay, FL means 1 by 2 pi RC. That if you write 1 by 2 pi F RC, that 2 pi F can be written as omega. So pi is equal to tan inverse 1 by omega RC. Okay, and for a perfect differentiator it must be 90 degrees. So you must choose the RC, the relation between RC and omega, such that pi must be equal to 90 degrees. Then it acts as perfect differentiator. So for example, for the case if omega RC is equal to 0.1, then pi is equal to tan inverse of 1 by 0.1, that means tan inverse of 10, which will be equal to 83.7 degrees. And for the second case, if omega RC is 0.01, then pi is equal to tan inverse 1 by 0.01, that means tan inverse 100. Tan inverse 100 is approximately equal to 89.4 degrees. So it is approximately equal to 90 degrees. If we maintain omega RC is equal to 0.01, then it acts as perfect differentiator. Then omega RC is equal to 0.01, that means 2 pi F RC is equal to 0.01, which means 2 pi into 1 by T into RC is equal to 0.01. So from this one, RC, at least it must be omega RC should be less than or equal to. So RC should be less than or equal to, okay, 0.01 T divided by 2 pi. So if this condition satisfies, then we can say RC, high pass RC circuit can act as perfect differentiator. Okay. Thank you.